Okay, this video is going to be just kind of going over this shape sheet. So figure out the shapes of elements as you're drawing the Lewis structures. Okay, so here's how this kind of works. So first thing, number of electron domains around the central element. So if this is your central element and there's electron pair, so just two electron pairs off of it, that means there's two electron domains around the central element. Okay, and that will always be linear in shape. Okay, so here you have an element, bonded, bonded. It doesn't matter if these are single bonds or double bonds, but there's no unshared pairs. There's just a shared pair of electrons, so a bonded pair of electrons and a bonded pair of electrons right there. So carbon dioxide is an example. Again, we're looking at the central element. There's two bonded pairs of electrons there, two bonded pairs of electrons here. They want to be as far as they can away from each other around the central element, which would be a 180-degree angle. So the bond angle should also be on here. You do need to know the bond angles. This angle from this bond to that bond would be 180 degrees. That's as far as they can be apart. Next one, if you have three electron pairs around the central element, it is trigonal planar. So that is the electron domain geometry. So the electron pair geometry is trigonal planar. So these are all in the same plane. If you have bonded element, bonded element, bonded element, then the shape of the molecule, the molecular geometry, is also trigonal planar. So whenever you have no unshared pairs around the central element, the molecule shape or molecule geometry is the same as the electron geometry. If we replace one of these with an unshared pair, so we take one of these off, one of these bonded elements, make it an unshared pair. So now we have, for example, water would look like this. So now we'd have like a bonded element like oxygen, hydrogen, hydrogen, oxygen. So you have electron pair bonded, unshared pair. So your electron geometry, there's still three electron pairs around the central element. So your electron geometry is still trigonal planar, but your molecular geometry just takes into account the atoms themselves that are bonded, would be bent. Again, this bonding was about 120 degrees, 360 in a circle. This is about 120 this way, 120 this way, 120 here. Down here, we'd expect this to be about 120, 120, and 120. An unshared pair takes about 2 degrees off that. So instead of being 120 here, it's about 2 degrees less than that. Here's an actual molecule that way. So this is bent in shape. Electron geometry, since there's a pair here, and pair here, double bonds don't matter. Electron geometry is still trigonal planar. Molecular geometry is bent. If there are 4 electron domains, now you have a central element with electron pair, electron pair, electron pair, electron pair. That is tetrahedral in shape. Okay, so all of these right here are tetrahedral for electron geometry. They all have, that'd be bonded pair, bonded pair, bonded pair, bonded pair. So 4 pairs around the central element. Bonded pair, bonded pair, bonded pair, unshared pair. Still 4 pairs around the central element. Bonded pair, unshared pair, unshared pair. Whoops, I said water earlier. I didn't mean to do that. Water has 2 unshared pairs. I forgot that around there. So I was wrong about up there. So these all 3 are tetrahedral for electron geometry, but they all have a different shape for molecular geometry. So if all of them are bonded pairs, it's tetrahedral for molecular geometry. If 3 of them are bonded and there's 1 unshared pair, it is trigonal pyramidal. Trigonal meaning there's 3 elements off of this. This would be the shape of a pyramid. And if it's bonded, unshared pair, it is now back to bent again. You might think that this is a 90-degree angle, but 3-dimensionally you can make this angle more than 90 degrees. They want to, remember, these electron pairs want to be as far away from each other as they can be. So this angle is actually about 109.5 degrees. Okay. Again, down here, these angles would be close to 109. Since there's an unshared pair, it would be about 107.5 degrees. Okay, it's about 2 degrees less since unshared pairs have more repulsion than shared pairs. And down here, it would be about 105 degrees because there's 2 of them. So that angle is a little bit less. If there are 5 electron domains, it's now trigonal bipyramidal. I remember that by going tri plus bi adds up to 5. So trigonal bipyramidal. I will not worry about the bond angles in this, but you've got different shapes here. So again, your molecular geometry matches up to your electron geometry if there's no unshared pairs around the central element. Add an unshared pair and it becomes called seesaw. Add 2 unshared pairs, it's called T-shaped. Add 3 unshared pairs, and we're back to linear again. Back to linear. These would all have an expanded octet around the central element. There are now 10 electrons around the central element. Everything before this would just be an octet of electrons around the central element. So this is now an expanded octet, more than 8 electrons around the central element. Those are toughest shapes to remember. And last one, you have 6 electron domains, so still an expanded octet around the central element. Everything here is 90-degree angle, by the way, 90 degrees apart. So octahedral is your electron geometry. Again, if there's no unshared pairs, still octahedral. If you replace one unshared pair with an unshared pair, it's called square pyramidal. 2 of them is square planar. All right, that's that. That was quick.